with this. We're talking about lean phase or dilute phase and dense phase conveying. And just a very simple question, and I think Karsten probably can answer this, is what is the two different phases? And the second part of the question is, why do we need two different types of conveying? Over to you, Karsten.
Well, thank you, Steve. Yeah, actually interesting to have a look at the two. Let's define lean phase for the start, and you mainly define the phases by the actual material to air ratio. So you're looking at how many kilograms of a material per kilogram of air that you actually have in the pipeline. So the strict definition on the lean phase is that we have between 0 and 15 kilograms of material per kilogram of air. And when you go above that, you go into the medium to dense phase. So in the lean phase as well, we try and keep the material in suspension. So you run the lean phase conveyors at a much higher speed, which is typically between 18 to 25 meters per second. And you make sure that you run it at a speed so that the particles don't actually settle in the pipeline. So they're completely distributed in the pipe as you blow them down the pipeline or as you suck them along the pipeline. So you can do that either in a vacuum or a positive pressure. In a vacuum, a typical analogy would be a vacuum cleaner, but you can also blow the material down the line. So that's the definition of the lean phase. And as I said, dense phase is a lot denser, and Heinrich can elaborate on that a bit more. Heinrich, if you want to maybe just have a look at the dense phase side on your side.
Yes, thank you, Karsten. I think my definition, or the definition I would like to use the most, is not necessarily my definition. It was taught to me through my peers through the years. But the definition of dense phase, a lot of people tend to suggest that the moment you go above a certain pressure or a certain velocity, they classify that as dense phase. But I think the true measure is when you convey material, obviously with air in a conveying line, be it through vacuum or blowing it. But if you go below the saltation velocity, so the saltation velocity being the velocity at which the particles fall out of the air suspension. So we are deliberately trying to keep the velocity low enough to move as slow as possible, which is counterintuitive. But obviously by doing that, we're getting much higher tonnages through the same size of pipeline.